Okay, guys, today our lesson is going to be on the Earth's layers. And by the end of the lesson, we'll be able to identify the three main layers of the Earth, explain the characteristics of each layer, and summarize three characteristics of each layer. I'll check this again. And I don't know what to do, right? And as we watch the video, I want you to pay attention.
It's 6,371 kilometers to the center of the Earth. Follow us down. We're going all the way to the heart of the planet. Our world is made of layers, a bit like an onion. And as far as we know, life only exists in the first layer, the crust. In the crust, you'll find the burrows of animals, such as moles and badgers. The deepest are made by Nile crocodiles and can reach depths of 12 meters. The crust is also home to ancient underground cities like Edinburgh in Turkey, an elaborate labyrinth capable of housing 20,000 people, complete with schools and chapels. It is thought to have been built around 370 years BC. The world's deepest mines can go down to around 4 kilometers. South African gold miners have found worms 2 kilometers down, but all life stops before 3 kilometers. Then there's the deepest hole ever drilled, the Kola super deep borehole in Russia. Some call it a gateway to hell, but locals claiming to hear the screams of tortured souls. At around 30 to 50 kilometers depth, we reach the next layer, the mantle. It's made of hot rock, which appears solid to us, but actually flows very slowly, just a few centimeters a year. These delicate shifts below can give rise to earthquakes above. In the 1960s, a group of scientists attempted to drill into the Earth's mantle. Although unsuccessful, new efforts are afoot with a plan to drill deep below the Indian Ocean. As we descend, the increase in pressure means that atoms become warped, and even the most familiar materials behave bizarrely. Crystals change from green to blue to brown, and rock becomes as malleable as plastic. 2,900 kilometers down, we reach the bottom of the mantle. See those two giant blobs? They're the size of continents. Scientists aren't sure how they were formed or what they're made of. They cradle the next layer, the outer core. In Jules Verne's classic novel, Journey to the Center of the Earth, Professor Otto Lidenbrock encounters an entire underground world replete with prehistoric creatures and the subterranean ocean. While the dinosaurs might have been a bit of a stretch, there is an ocean of sorts. But this one consists of flowing, red-hot iron and nickel, a sunless sea with its own currents and jet streams. This motion creates a magnetic field that protects the Earth from dangerous solar rays. The final layer is known as the inner core. It's 6,000 degrees in here. The pressure is so intense that the metals here have crystallized, forming a solid sphere at the very center of our planet. In reality, our little vehicle would have been crushed and melted long ago. And as for our driver, I think she'd better head back to the surface. It's a long way to go. Good luck!
So now we have some questions based on this video. Okay, so based on the video, how many layers does the Earth have? Who said three? Correct. Then can anybody name the layers?
The mantle.
The mantle, what else? The inner core. The crust. So if we have a inner core, we have a okay, so inner core, outer core, crust, and mantle. And on which layer does life exist? Correct. So we were correct. The crust, mantle, outer core, and inner core. Now, remember I told you to bring your eggs? We're going to do a comparison between the Earth and our eggs. Can everybody take out their eggs, please? Where your eggs? Where your eggs?
One store.
I have 6 eggs. I can come and give it to you.
Do I forget something? We need one.
You want to share? Okay, everybody on this side of it. You over there? Okay. Okay, so looking at your egg, what do we think the eggshell represents? Okay, and what do we notice about the crust on the egg? Right, it's hard. Now let's get to the other layer. Start peeling your egg. Everybody should know how to peel egg. What do we do to peel the egg?
It's right.
Okay, we start peeling our egg. What is the next layer that we are seeing? The egg white. And what do we think the egg white represents? Okay, so far, the eggshell represents what? And then the egg white represents what? Okay. Now let's get to what's the next layer?
The outer core.
The inner and outer core. So what do we think the inner and outer core is in our egg?
The yolk.
Okay, so let's find our next layer. Bring it over. The inner and outer core, the core. Just break it.
Alright. Double mandible.
Okay, so that's the core. Where's your core? We still
on the way.
Not the egg your life, eh? I got like I paid someone thought I could eat all these eggs right now.
No. Okay, so does everybody have their core? Where your core? Where your core? The core of the earth. What is the core of the earth represented? Yes. Okay.
Say do it.
Oh my god!
Okay. So that's the core. So let's break that. Okay. Let's read what we have on the boards. Let's read. The eggshell.
The eggshell represents the crust. The egg white represents the mandible. The egg yolk represents the
The
core.
core.
My heart's on the egg. Oh my god.
Okay. Everyone, you can throw away your earth now. Throw away your earth.
But Jason, don't show you.
See, I wouldn't even blame you for it.
Let's go. Throw it away. Break the garbage. All right.
Egg do it. How much eggs you plan on bringing? You can bring 6. You.
Everyone, if they just put on the eggshells and stuff
You hungry?
Okay, so now we are going to identify 4 characteristics of the Earth's crust. Crust that were So we're going to create a graphic organizer. Does anybody know what a graphic organizer is? What do we think a graphic organizer is?
Or organizer with grades and shirts.
Okay. Using the back. Okay, so based on what we're doing, what do we think our graphic organizer will include? Look at the title. Okay, so this is how our graphic organizer will look. Not exactly like this. So the first thing would be the layer. Does everybody see this?
If I could just use focus.
Okay, so the first layer we're going to identify the characteristics of is the crust. And then we'll write the information of the crust, about the crust, on the side of the characteristics. So we have 2 minutes to create that.
Here you go.
Right up on the board.
And that's still funny.
How many you eat?
Draw it.
Draw? Is it draw?
Just draw a line.
Just walking up our class and give us some of the characteristics. They still forget what characteristics is.
Layer.
Wait, what's...
That's something is on the desk. I'm making my time black. You do? You draw already? Need a pencil. Okay, so let's start the video. So we're finding, remember, we're looking for 4 characteristics of the Earth's crust.
What are 3 characteristics about the crust?
3.
The crust is the outermost layer of the Earth's surface. It is composed of solid rock and is the thinnest layer, ranging from 5 to 70 kilometers thick. The crust is also the coolest layer, with temperatures ranging from -40 to 700 degrees Celsius. Lastly, the crust is constantly changing due to geological processes such as erosion, volcanic activity, and tectonic plate movements.
Ready?
That's the fastest video I've seen.
Let's break.
Okay.
What are 5 to 70?
Now, based on this paragraph, somebody come and underline what characteristic they found. Okay, so that's one characteristic. Somebody find another.
That's a lot.
Keep this one.
Let's find another characteristic.
Running. When? Sweat.
Come to. Okay. And also the thinnest layer, and it is between 5 to 70 kilometers thick. So let's write our three characteristics. Just write three. Okay, one more minute. Okay, so we have the characteristics of the crust. What do you think we are finding the characteristics of next? The mantle. Okay, so now we're going to watch the same video, not the whole thing, but the part about the mantle, and I want you to write down some of the characteristics that you hear the doctor speak of. Get to some doctor.
30 to 50 kilometers depth, we reach the next layer, the mantle. It's made of hot rock, which appears solid to us, but actually flows very slowly, just a few centimeters a year. These delicate shifts below can give rise to earthquakes above. In the 1960s, a group of scientists attempted to drill into the Earth's mantle. Although unsuccessful, new efforts are afoot with a plan to drill deep below the Indian Ocean. As we descend, the increasing pressure means that atoms become warped, and even the most familiar materials behave bizarrely. Crystals change from green to blue to brown, and rock becomes as malleable as plastic. 2,900 kilometers down, we reach the bottom of the mantle. See those two giant blobs? They're the size of continents. Scientists aren't sure how they were formed or what they're made of. They cradle the next layer, the outer core. In Jules Verne,
We need to replay it. We need to replay it.
it's made of hot rock.
Okay, so that could be one. The mantle is made up of what? Okay.
Which appears solid to us, but actually flows very slowly, just a few centimeters a year. These delicate shifts below can give rise to earthquakes above. In the 1960s, a group of scientists attempted to drill into the Earth's mantle. Although unsuccessful, new efforts are afoot with a plan to drill deep below the Indian Ocean. As we descend, the increasing pressure means that atoms become warped, and even the most familiar materials behave.
What's another thing we could write?
Pressure.
Okay, so an increase in pressure can affect atoms, or the pressure in the Earth's mantle is increased. have some more information about the mantle. So the mantle is 1,865 miles thick, and this is the thickest layer of the Earth. So that's another thing we could write. The mantle is the thickest layer of the Earth, and it starts at 18.6 miles beneath the surface. It's mostly made up of iron, magnesium, and silicon, and it is dense, hot, and semi-solid like caramel candy. So anybody had caramel before? Okay, you see how it's not liquid and it's not totally solid. So that's exactly how the Earth's mantle is. So we can write some points from this. Okay, everybody wrote? Everybody good? Everybody good? I was talking to myself. Okay, so now we're going to find some information on the Earth's outer core.
Outer core. In Jules Verne's classic novel, Journey to the Center of the Earth, Professor Otto Lidenbrock encounters an entire underground world replete with prehistoric creatures and a subterranean ocean. While the dinosaurs might have been a bit of a stretch, there is an ocean of sorts. But this one consists of flowing red-hot iron and nickel, a sunless sea with its own currents and jet streams. This motion creates a magnetic field that protects the Earth from dangerous solar rays. The final layer is known as the inner core. It's 6,000 degrees in here. The pressure endures such motion, sunless as this one, consists of flowing.
Okay, so what is the outer core made of? And nickel. So that's something we could write. The outer core is made up of hot iron and nickel, and it has its own current, so it moves on its own. And what does the outer core do? Right, so it protects the Earth.
Red-hot iron and nickel, a sunless sea with its own currents and jet streams. This motion creates a magnetic field that protects the Earth from dangerous solar rays.
Everyone got that? One more minute. Okay, so just like the video said, this part of the core is also made from iron and nickel, and it's in a liquid form. And it's between 3,220 to 1,790 miles below the surface. And can somebody read the last one? Heated?
Heated by radioactive decay of the elements uranium and liquid chunks.
This liquid
This way.
churns.
Churns in the huge turbulent currents. That motion generates electrical currents. They in turn generate earth magnetic field.
Okay, so the movement of that liquid in the outer core, it causes the electrical currents, and this generates Earth's magnetic field. So we could write that it's made from iron and nickel. I think we already have that. And then it is heated largely by radioactive decay. And then this is the last layer. What is the last layer? Again, there you go. The inner core.
Is known as the inner core. It's 6,000 degrees in here. The pressure is so intense that the metals here have crystallized, forming a solid sphere at the very center of our planet. In reality,
Okay, so how hot is the inner core? 6,000 degrees, so that's a characteristic. And what else? And what has it done to the metals? Crystallize them. So that's something. The pressure is so intense in the inner core that it crystallizes the metals. Okay, inhale. It's extremely dense. Does anybody know what dense means? Okay, it's hard and solid. So it is hard and solid. It's made up of what two irons? What two metals? Iron and nickel. And the inner core spins. And it spins a bit faster than the planet. It is also insanely hot. How hot is it?
6,000.
Okay. She said it in Celsius, so this is it in Fahrenheit. It's 9,800 degrees Fahrenheit. And that's almost as hot as the surface of the sun. So we see why nobody could get to the center of the earth. Why do you think nobody could get to the center of the earth? Okay, based on our information we have. Do you think it will be possible for anyone to drill down to the mantle?
No, they'll get crushed before they do.
Okay, so they would get crushed from what? Okay, so the pressure would crush them. And we know if you can't make it past the mantle, you can't get anywhere deeper. Okay. Now our activity. I have paper plates for everyone, and we're going to make our own little model of the Earth's layers. And what are the layers of the Earth? Okay. And which layer do we live on? Okay. I have crayons. So we know the first, it depends on which way you start. You can start from inside going out, or you can start from outside going in. And be sure to label it and put your names. That's enough. Anybody need a pencil? No? Okay. You have crayon. y'all too. Don't get me started now. Y'all too good for my crayons now.
I'm gonna see you. Okay. I have to do better too.
Huh? Well, then you won't give me back. Hold on.
Nah, 3, 4. Just one,